We are discussing the 12th lesson, so that is about the indices, right? So this part I will discuss quotient of powers, right? So that means power divided by another power, how to apply the indices law, right? Let's see. Now students, see quotient of powers with the same base, that is very important one. Quotient of powers with same base, right? See, I'll explain you using an example. So this is my example. So see, 3 to the power 5, this is a power, right? So that should divide by another power. Here see, 3 to the power 3. Now you can see same base. What is the base here, student? That is 3. Here base 3, same base, right? So this one I'll simplify using one method, and same thing you can see here, 3 to the power 5 divided by 3 to the power 3, right? So you can see same question. So here I'll explain you one method, here another method, right? So you can find what is easy, right? Let's see here. Here I write the product, right? So that means expanded form of these two powers. 3 to the power 5 means 3 should multiply 5 times, right? So that means 3 should multiply 5 times, 3 into 3 into 3 into like that. So then denominator, 3 to the power 3 means 3 should multiply 3 times. So here you can see, student, multiplied. That means you can cut, that means you can divide the numerator value and denominator value by a number, right? You can see here this 3 and this 3 and cut, right? So if you cut 3 has 1, you have to write 1 here, so I have to mention that one. Here 3 you can cut, then you can cut this another 2 3, this 3 and this 3 you can cut. Same way this one and this one you can cut. Right, now here remain in the numerator, student, numerator, these are all ones, right? So if you multiply ones, only one is answer. Here you remain 3 into 3, right? So that is remain one in numerator, right? Not in denominator. Denominator is 1, right? Divide by 1 means no change to the number. Then this is my answer, but this answer I can write as a power. We can take value, that is another thing. I can write this one as a power. How? 3 into 3 means 3 to the power 2, 3 to the power 2, right? So in this same question, I'll try to get this power using other method. You can see base 3, right? So index is 2, here index 5, here index 3. That means how to take the index 2, base is 3, you can write one base, this index subtract this index, right? So indices subtract, right? So I write here answer in numerator, right? So that means from the numerator index subtract the denominator index, then I get base is 3, 5 minus 3 is 2. Then you can see here same question, right? Same question, you get same answer, 3 to the power 2, 3 to the power 2, right? So this method is easy, right? So this is the method using the indices law, indices law, right? So I'll explain you this index law, student, right? So earlier we explained one index law, here division, right? So I take a general form. You see, a to the power m, base is a, should divide by a to the power n, right? Base a, see, same base, right? Then how to take the answer using this index law? Base a, this index m should subtract index n, right? So this is the index law, right? So try to remember this one, student. Now let's move to some example, students. So here I will explain you 4 examples. Here you can see, right? So this is my 4 parts. So my example 1 is, student, see, 5 to the power 7 should divide by 5 to the power 3. So now I am going to use the index law, right? You can see both has same base, right? So this question you can represent this way also, right? So this is a normal division. If you use the line, same thing you can write. So now you can see here base 5, base 5, base is same. That means you can write one base, you can subtract the indices. That means 7 minus 3. Then you can take the index as 7 minus 3 is, that is 4. So this is the answer in index form, right? So using index law. Then I'll move to another example. See, student, so this is my question. You can see 6 times x to the power 8 should divide by 2 times x to the power 3. So I can represent this question this way also, right? So that is easy to simplify. Now you can see here 6 multiplied, here is a multiplication, right? X to the power 8. This index 8 is only belongs to x only, right? So that means I can write using this product, right? So here now product, 6 times x to the power 8. Here also multiplication. Now you can see here, student, this 6 and this 2 you can simplify. That means you can divide by 2, right? So this one can cut by 2, that is 1. This one can cut by 2, that is 3, right? So now you can write the remaining part. Here numerator 3 times x to the power 8, denominator x to the power 3, right? So that means these are the same base powers, right? So that means I simplify first step. X to the power 8 should divide by x to the power 3 means you can subtract the index. You can see 8 minus 3, right? So here number 3. So then I can simplify this index, that is 3 times 8 minus 3 is 5. Without multiplication I can represent the answer, right? Then move to another example, student, right? See here, now you see 8 times 8 to the power 5 should multiply 3 times 8 to the power 2 should divide by 6a, right? So here now multiplication, here also multiplication, here also multiplication, right? So I wrote all thing in multiplications, right? Now you can simplify numerator denominator value, right? What is value? You can see here, right? So in this next step I'll somewhat easy to you. Wow, this 8 should multiply by 3, right? So those are the numbers, so write those one together, right? Then 8 to the power 5 here, 8 to the power 2 here, then 6 times a is denominator. Now you can see here this 3 and this 6 you can cut by 3, right? So here 3 has 1, 6 has 2, right? Then this 8 and this 2 we can cut, right? So that means 2 has 1 2, 8 has 4 2's, right? So then I can simplify, right? So numbers already simplified, then this power should simplify, right? Right, let's see, number is 4, right? Then these all are same base, a base, a base, right? So base. So here multiplication mean product of powers. That means this index and this index should add, right? So a to the power 5, that means 5 plus 2. Then here index, no index means 1, that is divided. That means that index should subtract, right? So then 4 is the number. Here if you simplify you get a to the power 6, right? So that is the answer. Next move to another example, students, right? So different example, this one, 3 times p to the power 7 into 2 times q to the power 3 should divide by p into 6 cube, right? So here between these two multiplication, between these two multiplication, so you can separate the numbers, right? So see here, this is the product, right? So then I'll separate the number, that is easy to me, right? No need to do this one, right? So here see, 3 and this 6 you can cut, right? So that is 3 has 1 3, 6 has 2 3's. Then you can see here number here 2, here number 2. That means these two you can cut, right? 2 has 1 2, this one has only 1 2. Right, now here see no numbers, only powers, right? Algebraic powers. Then you can simplify here, p to the power 7, denominator p to the power 1 here, right? So those things you can simplify, and also q part also simplify, right? Now that means here p to the power 7 remain, q to the power 3 remain, here p into q remain, right? Now this one can divide, means simplify the indices, that means p to the power 7, right, subtract p to the power 1, so that is division. So that means these two can simplify, and also these two can simplify, right? So those are the same base part, right? Now see, p to the power 7, here index 1 you have to subtract because of division, here also q to the power 3 you have to subtract 1, then you can write as answer p to the power, here 7 minus 1 is 6, here q to the power 2, right? So you see. Okay students, now we'll move to another different example, right? So in your exercise book also has this type of problems. So this is my question. You have to write 5 pairs of positive integral values for simple m and n which satisfy the equation a to the power m should divide by a to the power n. Answer is a to the power 5, right? So values of m and n, integral value, that means positive or negative values. Positive integral means positive integers, right? Positive integers, right? So take the equation, student, right? So this is the equation, a to the power m divided by a to the power n. You can see here, if you see the left hand side, this is the division of powers, right? Quotient of powers, that means if you simplify, base is same, that means one base a, m should subtract n, right? So that is the index law. Then you can see, student, this both left hand side and right hand side same base, that means what happened, indices should equal, that's right? So otherwise these are not equal, that means you can take m minus n value should equal to 5, so that is a result. So now you can select numbers for m and n, if you subtract, answer is 5, answer is 5. See, we want only 5 pairs, right? So see, this is my m, this is my n, right? Pairs means m value and n value, right? So I'll put I want 5 pairs, I'll put m as 6, right? So I can select any number, positive integral value, then if you subtract, number should be 5, that means what is the number you have to subtract, that is n, that is 1. So 6 minus 1, that is 5. So this is one pair, 6 and 1, right? So then I select m as 7, 7 minus here number 2, right? Then if I select number 8 for m, 8 minus, that is 3. So this is another pair, right? So I wrote 3 pairs, right? I want 5 pairs, right? So then I put m as 9, so 9 minus, that is 4, right? So then I can write another pair, 10 minus 5, right? So this is the 5 pairs. So you can write so many pairs, right? Okay, now coming up next part, students, right? Keep in touch. I'll discuss with you negative indices. Negative indices. So keep in touch with Maths Globe YouTube channel.